Hello, welcome to the first video on this 10-part series on complex numbers. Hopefully by the end of this series you will become very familiar with complex numbers and even find it an easy topic to grasp. So in this first video we're just going to cover a basic introduction, what are complex numbers, and first thing that you should really try and do is type into your calculator the value of square root -1. I'm going to do it myself right now. Calculator next to me. Now the square root of -1 should come up with math error if you don't have the imaginary setting on your calculator. Depends what calculator you have. But in this video series we're going to define the square root of -1 as I. And consequently, if we square, so if we put the square root of -1 to the power of 2, so if we square it, what does this equal? Well, it equals -1. But it also equals I squared. So another thing we're just going to note at the start here is that I squared is equal to -1 and that I is equal to 1. So as a set, the complex numbers are just all the points in the xy plane. And so we write a complex number. We either give it a definition of z or this w here of x add iy, and namely same here, iy. Okay. And so if we consider a plane of axes along the, we can see that the imaginary component of this complex number is attached to y, and the real, so I'm just going to put a little bit of notation here which is good to learn. So this attached to the y is this im in parentheses z is the imaginary part of the complex number, and the x is the real part of the complex number. So we could namely label these axes differently than x and y, then our Cartesian. By the y-axis we can just put this is the imaginary plane, and then this here is the real plane. And so we had the complex number 3 add 2i. Well, in actual fact, this is going to correspond to the coordinates 3, 2 on the complex number plane. So along 3 in the real plane, and then up 2, this is 3, 2 here. And it's really that simple. It's really that simple to start off with. So without further ado, we'll go into sort of some operations of complex numbers. So we'll look at addition, subtraction, multiplication, and something that's a little bit harder, but division. So let's look at how we add complex numbers. So addition. Now let me, it's good to just start with an example here. So we have the two complex numbers 3 add 4i add 2 add I. Okay, so what we actually do here is add the real parts together and the imaginary parts together. So we're left with 5 add 5i, like so, and that's the that's our new complex number that we form by adding those two together. So a really quick example that you could try and pause the video for would be maybe 2 minus I add 6 add 2i. Okay, and essentially what we're going to do is add the 2 and the 6 to give 8, and we have minus I, add 2i, which gives us I. And that's our complex number form there. And really what we've done here is shown that we can subtract complex numbers in a similar way that we add them by looking at that previous example with negative I add 2i. Well, so we have the complex number 2 add I, and then we want to subtract 3i. Well, it's this simple, it's just 2 minus 2i, like so. So there's no real part of this second complex number here. Therefore, all we need to do is subtract the imaginary parts of the complex number. Okay. Multiplication's it's not too hard. It's not too hard. You just have to remember the rule that we stated at the start, which is that I squared equals negative 1. So let's consider 1 add I cubed, or in other words, 1 add I multiplied by 1 add I squared. Now 1 add I squared is going to come to, so quickly, 1 add I, and it's going to be multiplied by 1 add 2i add I squared. And we can now change this to 1 add I multiplied by 1 add 2i minus 1. And so the minus 1 and the plus 1 are going to cancel out, and we're just going to be left with 2i here. And so we're going to multiply through again, so we're left with 2i plus 2i squared. And again, the I squared is going to cancel down, so we're left with 2i. It's going to cancel down to minus 1, sorry, so we're going to be left with 2i minus 2, or minus, and I'm just going to write that in the proper complex form, add 2i here, like so. Okay, so it's really quite simple. You multiply how you would a normal number, so you multiply the imaginary number by the real by the real parts, and the imaginary parts by the imaginary parts, and you're left with a complex number at the end. Sometimes you're not. Sometimes you're not. Okay. Now, quite quickly, there are four ideas we want to go through before we cover division, because we could go straight into division, but I think looking at these first will give a better understanding on how we actually divide complex numbers, because it's a little bit more, no pun intended, complex than the other operations. So consider the complex number 4z equals x plus iy. I've already shown you two of these terms, so the real part, re parentheses z, denotes the real part of the complex number, which is the x part, or the x coordinate. And so, consequently, the second part is the imaginary part, or the y part, the y coordinate, the imaginary plane. Now, next we're going to look at the modulus. You may have seen this in vectors before, but the modulus of the complex number, which is literally just using Pythagorean theorem. We're going to denote the modulus by r, this value r here, and it's simply the x value squared plus the y value squared, and then square root the sum of those two. And this is actually the distance of z from the origin. If you're considering a xy graph. And finally, what we're going to look at is the complex conjugate, which will be a new theory here, but all the complex conjugate really denotes is that if z equals x plus iy, then z bar, z hat, or whatever will equal x minus iy, like so. And that's what we're really going to go into here. Just really quickly, one more notation that we will look at is that modulus squared is actually equal to the complex number multiplied by the complex conjugate, like so. So let's look at division. Well, dividing, we're taking two complex numbers. We're taking w and we're taking z. And this is the operation essentially. But this can also be written as w times a bar over z times complex conjugate, because we've essentially times top and bottom by a value, so that could just cancel down. Those are both the exact same thing. Okay, well, what do we actually have? What does this also equal? Well, we have one complex number multiplied by our complex conjugate over, and we know that a complex number times by its complex conjugate is equal to this value squared. And why this idea is quite important is if I assign some values, let's say that our w is equal to 1 minus 2i and our z is equal to 3 add 4i, and we divide through by both of these, then in order to solve this problem we're going to have to multiply top and bottom by the complex conjugate of z. So we're going to multiply by 3 minus 4i over 3 minus 4i here. And if we quickly just skip past all the complicated, not complicated but sort of intermediate maths, we're going to be left with something like this. 9 add 16. At the bottom I've just cancelled the I square really quickly, which should give us 3 minus 8 minus 10i over 25, which should give us minus 5 minus 10i over 25, which should give us minus a fifth minus 2/5 I, like so. And so now part of this, and so now we have our real part of our new complex number. I'm just going to call it w over z, and we have our imaginary part, like so. And division is a little bit harder, because you've got a combination now of multiplication, of subtraction, of addition, and obviously dividing through, like so. Think of it, a way I like to think of it, and the Professor may not be happy with you explaining it like this, but think of it almost like rationalizing a surd. Okay, back in GCSE level, or you know, wherever you come from, it's almost rationalizing a surd. So I think that's all I'm gonna cover for the introduction today. The next lesson we're probably look into more the polar representation. So thank you.